These are the 6.3 and 6.4 notes, combined logarithmic functions and their graphs. So we need a way to undo the exponential function, and that is what we call a logarithmic function. The logarithmic function will return the exponent. Okay, so we've got to keep in mind that here, and I apologize for the spacing, when we write x equal log base b of y, that's the same as y equals b to the x. The logarithmic functions for a given base for an argument will return the exponent. So let's talk about some basics of logarithmic functions. And we are going to start up here with our standard basic exponential parent function. A equals 1, no adjustments. Y equals b to the x. So I like writing it this way. B is my base, x is my exponent, and as I write it as a logarithmic, I'm going to write with these with the same variables. So the x in both of those equations are the exact same x, the b is the exact same b, and the y is the exact same y. Okay, and we can go back and forth. We can take an exponential and write it as a logarithmic, or we can take a logarithmic equation and write it as an exponential, which is what that next line does. So down to a couple of properties that are going to make your life a little easier. When we have log base a of 1, and keep in mind I can put a little question mark here, I can rewrite that as an exponential to have this make, or put this in the format that we're used to seeing it. This means a to some exponent equals 1. Well, we know that anything raised to the 0 power is 1. So log base a, where a is any base of 1, is 0. This next one, log base a of a. Well, that means my base a to some power equals my argument a. Let's see if I can color code here so that we can keep our a's straight. Well, it's going to be a to the first power equals itself. So anytime you have log base a of a, you're going to get 1. Log base a of a to the x, and we'll go over properties some later too, is our x, and a to the log base a of x is also x. These are the properties of inverses. So if we're saying the exponential and the logarithmic function are inverses, if we do one and then the other, we end up with what we started with. Okay. Here we go. We want to write each of these in logarithmic form. And so I am going to work very hard to not think any harder than I have to. And I'm going to write that up there. So in number 1, I got 4 to the negative 3. So 4 is my base. Negative 3 is my x, my exponent. 1 over 64 is my y. So I'm going to rewrite this as log base 4 of 1 over 64. And that should equal negative 3. 2, I've got log base 5 of 1 over 25. That equals negative 2. Not actually doing any math here. We are just writing these, rewriting these as a logarithmic equation from our exponential. 4, I got log base 11 of 1 equals 0. That matches what we said up above. Log base anything of 1 equals 0. 5, I've got log base 6 of 6 equals 1, not negative. 6, I've got log base 6 of 1 over 216. Notice the desensitization. of those negative exponents. 7, I have log base 17 of 1 equals 0. And 8, log base 17 of 17 equals 1.